Yeah, we are live.
Right.
So Anurag, you see many more Tumblr-like rover models.
Well, it's becoming popular, so I've seen quite a few of them on the toy level too. And then yesterday I saw this what robot to save emergency robots, and then there was this construction robot that was like drawing lines. So
The
it's
construction robot is
popular.
also a two-wheeler.
It was like a caster wheel plus two wheels. But almost tumbler with a platform. If you widen the tumbler, then it becomes that.
Mm.
The one red shared, that is also a two-wheeler. That one is almost an A4 paper-sized platform, but it's still two-wheeler. Why don't we bring them up one by one and just look at them then? Let's see. Who's sharing?
Okay. So
Closing
I
a
think
bunch of
I needed to catch up on that. But the one that Red shared and the one that draws it looks like a clever idea. The one that draws the layout for construction. Okay, they're not really two wheelers, right? They have a caster, and it doesn't look like they self-balance, right?
Wait, what?
Wait. It's a huge difference. By the way, there's an intermediate possibility that the casters, when you want to vest, but other times you have
Hello?
two wheels only moving around.
Right. Yeah.
I don't know. I think for an earthquake, I'd prefer the Japanese moon robot. You know, the ball.
Hello? Can you guys hear me?
Yes.
Okay. I think my mic might not have been working before. All right. So which one are we looking at now? The construction robot?
Yeah, this is the construction robot.
And this one is a caster. Is there a diagram of its underside or something? It looks like it has a.
We can see a caster right now.
Oh, okay.
When
Is it a caster or is it the pen with which it's writing?
Well, that'll still be a third leg of the tripod, right?
It looked like a wheel. It had a depth.
What is the company? Like
Dusty.
And Dusty.
Now, if you scroll up for a second, it said the name of the company. Dusty
Robot.
You see?
BIM-driven layout construction. Nice. Pricing.
What is BIM?
Building information management, something like that. So it's like a field in construction. So
yeah.
So the buildings are becoming smarter. So it's a relatively new field called BIM. It has been there for some time, but yeah.
But this sounds like building construction or smart buildings. It looks like construction, right? BIM.
I'm looking at the Roomba that also has two wheels and a caster.
Yeah, indeed, yeah. And so, Venkat, on Discord, you were saying that one of the reasons is that controlling two wheels is just easier.
Yeah. So the third wheel is passive, but if it's two wheels, you're just doing differential steering, right? If you have three active wheels, The third one either has to be steered or be a caster. A caster is like mechanically limited. 4 wheels, you definitely have to do proper, like, Ackerman steering or something else that keeps it stable.
4
And
wheels,
with
you need suspension.
also,
If you have 3 wheels, you're stable wherever you are. But if you have 4, you have to have suspension. It's a big step.
Yeah, if you want higher performance, but I think
No,
for simpler situations, if you have one off, it just becomes a 3-wheeler, and if you have 2 off, it becomes a 2-wheeler.
then you have to have much more sophisticated feedback, because you need to not give power to the wheels it's not touching.
Yeah.
And it affects your steering.
Or you'll degrade the performance criteria.
You can
Because
always do that.
the one interesting thing about independently driven motor wheels is that you don't have the differential slippage problem that you have with a single transmission on a regular
Yeah.
car. So you don't have the problem of one wheel is spinning and the other wheel can't get traction. They're not coupled, so it's relatively simpler. What other ones? Let me share.
This was the one, rescue robots.
Yeah, this one, if we can find a more detailed diagram, I'm curious, because just looking at the physical appearance, it looks like the center of gravity may be below the axle. Okay, but that would actually be lower performance, because regular pendulum will actually be harder to control.
Okay, this is the robot.
Those regular wheels are wheels that can also move sideways.
They looked regular. This actually looks a little bit like the wheel Yasha was trying to design. All right.
These are dome shaped. I don't know if you noticed. They're hollow inside and dome shaped.
Yeah.
What is that good for? Does that give you better, let's call it suspension?
I think they're more like bumpers.
Mm.
Yeah, I mean, if there's compliance, it might be serving a suspension function as well. Lots of ads.
Yeah, if you are not logged in, then yeah, ads are forced on you. This is something else.
I don't see how it can be bumpers, because the axle is connected directly to the part that sticks out the most. So if you bump into something, all the force goes into the body of the robot.
Yeah. So yeah, unclear what it's for. You're right.
I mean, it protects the tread. Robot Smurf.
Yeah.
But I said before, when you got disconnected, I like the Japanese moon ball robot much more for this kind of application. Maybe it's not as good, but the Smurf robot has all these things that can get stuck, on pieces of concrete or drywall.
at least the cooperation between Europe and Japan. I saw the
Yeah,
flag.
it seems so. Yeah.
Yeah.
because it's funny you talk about the Japanese lunar rover. Yeah, because I was about to say something similar, but for different reasons. Because I'm still wondering what is the appeal of two-wheelers. Okay, because for the tumbler it's really nice because it's fun. Okay, we have the inverse pendulum and so on. But here the examples we've seen, they are not doing the same, right? Okay, they have two main wheels. They have two motor-mounted wheels, but they have a caster, or they have, for example, the last one we saw for inspection. This one, yes. Not sure what it is. It looks like something that's going to wear pretty quickly. Looks like a camera or something like that. Or I thought it was a head with the ice and it was self-balancing, but apparently not, right? Okay.
It seems to be a light.
But the point of two wheels, maybe, so the simplicity that Venkatesh talks about, that looks pretty clear, but also the form factor, and that links to what Meyer was saying with the space robot for Japan, is that when we send to space, of course, the form factor and the weight become very important, and we can see they can become very small. And the Japanese one actually can, it can fall on itself, so it becomes a small sphere. Okay, and if I'm not mistaken, it's something like 500 grams total. Okay, the whole robot. Okay, and once it deploys, okay, the wheels open, and in the middle you have the camera unfolding automatically. But it also has a caster. Actually, it deploys a
Oh,
caster.
but just stop you a second. I'm sorry for interrupting you, but before you
Sorry.
move on, you notice how it's peeking under. That's why they have the camera on the rod. Can you go to that previous picture where the camera was looking under the rock?
Which one?
You not this one. This one's looking at the ground. But you had one where it was on top of a piece of concrete and was looking underneath with a green robot. It has to do with the form factor of two wheels.
But it seems pretty rugged, right?
Yeah, Mayor is right. But this is a very special thing in this case. In this case, they're exploiting the two-wheel form factor to allow the camera to be horizontal or vertical. So it's without adding more actuators. Whereas in a 3 or 4-wheel platform, you would have to independently actuate the camera boom to go vertical or horizontal.
But you can do more than that. You can also use a camera to look underneath. It's like the camera is on an arm all the time, and like you said, you can move the arm without adding any motors.
And this one, I don't think it's an inverted pendulum. I think this,
Anuraj, can you stop a second? I want to point out that it's a two-wheeler. Most of the time, when you're moving, it's not self-stabilizing. When you want to play with the cameras, then you go into self-stabilizing mode.
Yeah.
So it's very clever, I have to say.
I don't think it's self-stabilizing though. I think what it does is locks the wheels with friction to the ground, so the brakes on basically, and then torque them so that the body spins up. Because the movement does not seem like a balancing pendulum to me. It looks more like, you're holding the wheels tight and like swinging the arm up. And also the body is so heavy that I think the CG has to be at the axle or below.
I think they have a mode where you see it rolling around with the camera on top.
Yeah, but that's, I think, not in balance mode. Because the center of gravity is not that high. The center of gravity doesn't seem that high. But
Oh.
yeah, I don't know. We'll have to look at the documentation to see how they actually do it.
Notice that the wheels are
Yeah.
moving
This
sideways, I should say.
That wheel is also designed to take advantage of the terrain, right?
yeah, it catches on to any roughness. Yeah, the way it's lifting kind of looks like it's locking the wheels and then torquing up the body. But yeah, maybe it has a balance mode too. It would be interesting to look at the details here. I shared a page. You can look at that for a minute if you want.
Where?
It should be in.
Is it possible that they say why they chose this design?
I asked ChatGPT, so I can show what ChatGPT thinks is the reason. And I also shared a picture of the underside of the Roomba. I thought that would be
Where
interesting.
did you share it?
I shared my screen. I guess it's waiting in the bottom.
Okay, I put it.
Who is actually the? Oh, somebody has to stop.
Yeah.
Oh yeah, you have to stop sharing before. Okay, yeah, I thought this would be interesting to look at. There's a picture of the underside, so you can see. Yeah, that's a caster and it's two wheels. It's but this one I think might have to self balance a little bit
Why?
because the tripod doesn't look.
You don't know where the weight is.
Yeah, we don't know the well weight. Yeah, the front might be lighter because that's the sucking part. Anyway, so that's one thing I wanted to share. The other is, let me. Yeah, I asked ChatGPT, which is these days how you solve problems of asking. Okay, so it says simplicity and parts count. That's fine. This is the point I was making: omnidirectional turning in the simplest possible way, the differential drive model. Compactness, I think, is important. The footprint is very low. Yeah, control is cheaper. Previously, you couldn't do this without MEMS IMUs easily. Let's see, use case alignment. Yeah, this is like it's making shit up.
Just listening, they remind the Segway.
Yeah.
Segway was that was self-balancing, right? The Segway.
Yeah, and that I think had a mechanical gyroscope, not MEMS. That was MEMS gyros were invented, I think, 2006 or 7, and it might have been older than that. I don't remember. But also, it was. Yeah, it would be worth looking that up to see exactly how it worked. I remember seeing a talk when it came out. Yeah, I think omnidirectional turning is the most obvious one. But the one thing I started thinking about just today after we started discussing this is it's actually valuable to be able to make very tall robots. If you think about it, why did humans evolve bipedalism and then the other monkeys and apes are like partially bipedal, right? Mostly they crawl around on fours, but while climbing trees, they kind of become more vertical. And for short periods, they can go around on 2 feet. But humans became bipedal because I think if you're a combination forest tree climber species, but also running on the plains and hunting kind of species, the advantage of like being upright and having like a much larger field of vision from our elevation is more than makes up for the higher stability of being on 4 legs. So if you imagine, like if you crouch, you're probably about 2 feet high, so your field of view is very limited. If you stand up, it's somewhere between 5 and 6 feet, and the field of view will be much higher, especially if you're in the savannah and you're competing with like zebras and lions and stuff, which are all like naturally taller on 4 feet. So there's interesting trade-off there, I think, to being bipedal. And if you can solve the balancing problem cheaply enough, there's a lot of advantage you can get. For example, yeah, 2 of your legs can evolve into hands, and now you have like combo manipulator and motion things.
But what you're really saying is that it allows you to change your height without increasing your body mass.
Body mass is one, I think, but I think the more important thing might be horizontal footprint, right? When you're standing up straight, your feet occupy like less than like 1 square foot of space, which means you can stand in very narrow places. Like, you run away from a lion and crawl between two rocks, you can just wait it out, maybe something like that. So I think it helps to have a very narrow footprint so you can get into narrow spaces, because the earth is mainly a horizontal space with vertical obstacles. So if you can like get into narrow spaces, more of the surface is accessible to you.
I'm trying to imagine a place where human can go and a goat can't. Goats, by the way, can also stand on 2 feet. While
So
they're
they're
leaning on a tree. But
yeah, and they can climb certain trees. Like in Africa, they have that very broad, heavy branch tree. I think it's a baobab or something.
Yes,
And
well,
yeah, the goats climb up on the lower branches of the trees, and cats can do that as well.
no, but even if when they don't climb, they stand on the ground and with 2 feet down
Yeah.
and 2 feet up and reach. So
If you
Yeah.
compare the best human climbers with the best goats, I think humans win. Like Alex Honnold, the guy who did the free climb of the mountain in Yosemite. That one, I don't think a goat could climb. It's like pretty much a sheer vertical cliff face,
no,
and he
no.
did it without ropes and stuff. Yeah,
But I think like having like dexterous hand also might have played a role, because like we can build tools that like
Yeah.
enhances the abilities. So maybe that set up some sort of loop. Basically, we lost some strength but increased the dexterity, right? So chimpanzees have like stronger arms compared to us, but they don't build tools like us.
I don't know what you
how,
mean
how
by
do
build. They do.
But
Simple.
like not as complex as us, right?
yeah. I mean, many other
Like
apes and monkeys, as well as birds, make tools, but definitely we have more complex. But they all have equally good opposable thumbs. Like if you look at a monkey's hands, they're the same as ours, basically. So it's not the manipulation capability that's higher. I think it's that plus higher intelligence. Like they can manipulate as well, but they can't think through as complex designs. But I think two more robots are worth looking at now that we're talking quadruped to biped, like uh, what do you call that, morphing form factor. There was the Boston Dynamics one that has wheels and
Yeah.
two forward legs. I think I forget what it's called. Is it? That's not Atlas, is it? And then Unitree came up with another similar one. If somebody can remember the name, let's see. Boston Dynamics wheel.
Unitary Go right now. Yeah,
Oh, it's called
G1.
Handle. The Boston Dynamics one is called Handle. What? Yeah, I just shared.
Very loud.
This is a big,
And it's
heavy
close,
robot.
and it's close space as well. So but it's something we touched on a few years ago. Is there is also a difference between wheels and legs, right? So here's a mixture of both, but several properties we talked about are proper to legs and maybe not to wheels.
Yeah, this is a good example of like merging wheel and leg form factors, right? Uh, it's doing both. This feels slightly weird. I think we are looking at the robot's back if you anthropomorphize it a little bit, because I think of it as having forward knees, but or backward knees.
So Mark River, was running Boston Dynamics. He started a new institute called RAI Robotics and AI Institute after leaving Boston Dynamics, and then he's doing this. Those guys are doing this bike-like stunt robots.
Oh, it's not easy to balance bicycles.
Oh yeah, bicycles are a whole different kind of two-wheel. Hoo-hoo.
But if we're talking about balancing two legs, I saw a project for gyroscope backpack that people wear. As you get older, you often get balance problems. So you have a gyroscopic backpack, which has two functions. The first one is it increases your weight, so it makes your balancing easier. But also, if you start tipping, the gyroscopes prevent you from falling. So it's interesting if you could add a balancing system onto an existing robot.
Oh, yeah, I was also thinking about that 3 and 4 wheels, if they tip over, there's basically no recovery unless you add another like crutch-like mechanism to lever yourself back up. Whereas a two-wheeler, at least in one dimension, the pitching dimension, it can get back from nearly a 180-degree fall or higher maybe.
Unitary is going public. I think recently.
Unitary is Chinese, right?
Yeah.
G1.
Oh yeah, they're going public and they were making some announcement that it must be non-military, something like that.
Yeah, I don't know how much I believe that sort of thing about anything coming out of China. There will be some shady CCP connection and dark division that's making the military equivalent.
I'm not sure how they could enforce that. Anyway.
Yeah.
But
An
this
interesting
product,
announcement.
so they are also selling this home fitness equipment. I don't know how that's related, but
Wait, just 1 second. That's by the same company?
yeah. But I think they are like making some sort of what is it called? The human wearable.
Okay. It is robotic arm for resisting your non-robotic movement.
Is that a robotic arm? It looks like a cable pole.
Yes. It says it has a built-in motors. It cleverly controls resistance from start to finish, and it can do all sorts of modes like rowing and so on.
Okay, but the main attachment is a cable. I don't see a robotic arm. Okay.
Because the compressive strength comes from our arms.
Okay.
Hangzhou.
Their 4-leg thing can also do 2 legs, right? Like I think I've seen a video of mixed mode, like 2 and 4 leg. It's playing with a tiger.
They have no wheels, right? It's all about the legs,
Yeah.
right? Yeah, apparently.
Interesting.
Okay. I had.
Yeah, and I will share. So Mayor was talking about this spherical robot, right?
Yeah.
Well, there's a robotic ball too. Yeah.
Yeah, so this is like a ESP role.
Yeah.
Basically, you can build it with the stuff available on Amazon and some Arduino customized boards.
Yeah, but obviously it's not as good for climbing and things like that.
We saw some for swimming. Swimming, it may.
Yeah.
We saw some examples for swimming. So swimming is maybe better with that than with legs, basically.
Yeah. This is a interesting sort of like design space because you can make it very simple, which is kind of like a hamster running in a ball. So you can put a simple tumbler type robot just inside a sphere and then do the hamster ball kind of configuration, but you can also do things like sliding masses around, which makes it very interesting because then you can do things in underwater robotics. So there was a robot I saw in the late 90s by a professor's name was Naomi Leonard, I think at Princeton, where it was a spherical robot with sliding proof mass actuators that could like glide around underwater. So that's actually a good segue point because I wanted to talk about my other topic as well. Let me share something here.
Can you show a picture of that robot, a spherical underwater robot?
This is really old, so I don't know if anything will be online.
So my lab in Helsinki used to have this underwater spherical robots in the early 2000s, something around that.
Gulab's underwater spherical robot.
Yeah, this is the professor I was mentioning. I think she was one of the pioneers of this style of robotics. But she looks like it's mostly newer types of robots now.
So, but did it have holes in it?
I don't remember.
Here, let me. Well, the pictures aren't very good, but let me share a page.
Are you sharing something?
Yeah, can you put it on? Yeah. Okay, so like I said, the pictures are nothing special, but it's spherical and it's underwater. And it seems to be using, just a second, here.
Sliding masses?
No. It's using thrusters.
Oh,
See the
okay.
hole where they pull water in and push water out. And, all the usual stuff.
Yeah, that's the spherical form factor has, I guess, an additional valuable property in water because it's also a pressure vessel. So if you're designing like an autonomous battlescape type thing, it can go much deeper if it's spherical.
But it has huge holes in it.
Well, not this one, the sealed versions of the design. So you would still need at least a couple of holes to do ballast, but that can be external to the main body.
Right.
Yeah, this would be fun.
Well,
Wonder if we can think of a simple way to make our Yakusaur slightly aquatic.
First, we need to make it waterproof.
Put the whole thing in a box, seal the rotating joints, and see what happens.
No, you don't need to do that. You can put the whole thing in a ball.
Oh, yeah.
Then it's waterproof. It just can't go underwater. We saw the other one you showed.
Yeah.
It was really a Yakuza in a bag. Wait, do they have another research video? Yeah. Okay. Moving in a straight line. Turning on itself. That's it.
Now, same as two-wheelers on land, it's not immediately obvious to me why a spherical water robot is that useful unless you're going to super extreme depths. It feels like a more regular boat or submarine shape, cigar shape might be more useful.
Yeah, but people keep on building them.
Yeah. I think this is still a marginal curiosity. Most people who build UUVs build them in like cigar-shaped form
Yeah.
factors. Like all the military UUVs I've seen are all, they basically look like modified torpedoes.
Well, that could be part of it. It's much easier to get into a swimming pool by rolling it in. And if you were militaries and you have torpedo tubes.
Yeah, you can just launch it. Yeah. I almost worked at a oceanographic institute that was running a fleet of UUVs. Didn't get that job. Otherwise, my career might have been very different. All right, let's see.
Well, let me ask you this question. If you were making the equivalent of a Yakuza for underwater, would it be simpler or more complex? Forget about the mechanics of being waterproof.
I think it would be more complex. I mean, you can't forget about the mechanics of making it waterproof, but
No, I'm ignoring that.
so
intentionally.
that is a whole separate class of complexity. But I think it's more complex because you are operating in 3D. So first of all, you're maneuvering in 3D and you're doing full six axis control, right? Yaw, pitch, roll, and X, Y, and Z. So you have to do all six, and yeah,
Yep, but I don't have wheels. The question is,
you
if
still
not
have
having
propeller
wheels,
thrusters. So if you look
that's
at
my question. That's my question. Do you think you can make a simpler movement mechanism?
You could just be on the sea like this mission with Red Shed.
this is a floating
It's
boat, right? It's not.
yes.
Yeah, this is the
But
topic
in
that
terms of
got me interested.
control, it would share something with something that goes underwater. Just it
What?
becomes flat, right?
Yeah, but something has happened. I think it's
Yeah.
not showing the
It lost
data
its
anymore.
telemetry. Yeah, they're simpler and there is less energy intensive. Like on the surface, you could have a sailing robot. So sails, you only need enough energy to control the sail, not to drive the boat. But sailing is a much more complex mode of actuation to control than propeller and a rudder, or a propeller and those, what do they call those, elevator plates, I guess, on submarines. Yeah, I have one I can share as well. So far, yeah, you guys remember a couple of years ago we had David Lang as a guest on
Yeah.
our call, right? The Open ROV guy. So the Open ROV project got bought by this company so far because it couldn't survive as an open hardware project with Chinese competition. So this company bought the IP, and some of the Open ROV people went to work for it. But this is, I think, their main product now, which is this buoy, and it's, yeah, about as simple as you can get. It's just sensors. It doesn't.
Doesn't move. It
Yeah, it
doesn't
doesn't
make it
move.
much
It
of
can
a
drift with
robot.
the currents and stuff, but it's just a sensor platform. So this is the simplest answer to your question, Mayor, which is, yeah, just go wherever the waters take you. I think you suggested something like that long ago about tumbleweed on land.
Yes.
So this is like
Yeah.
ocean tumbleweed.
Yeah, but you can't control your motion.
Yeah.
So it's not a robot.
Maybe you can control to a limited extent by, I don't know, controlling how much you respond to the current. But yeah,
It's the
this is a,
difference between trees and like animals, right?
but yeah, the thing that was interesting me, if you combine this idea of like ocean robots out on like international waters where nobody has jurisdiction, and Anuraj's idea of like just putting wallets on these robots, you essentially have sovereign robotics, right? Post state, this thing can be out there, nobody needs to own it. It has a crypto wallet, if it's small enough and stealthy enough, it'll actually be kind of hard to find. So if you have a network of thousands, even like big navies could not take it down. Especially
But
if
like,
it has
are there some regulations? Like, for example, in Antarctica, there are some regulations, right? You cannot just.
I mean, they're
go
not
into some-
regulations as such, right? They're international treaties. If you have big enough guns, you can violate them. Or if you're small and stealthy enough and you can get yourself to Antarctica, who's going to enforce it, right? But I was thinking, like, the simplest way to do this is I was just reading about bristlemouth fish. Have you guys heard of this? So bristlemouth, by the way I learned about this is actually also through David Lang. So he was involved in a project being sponsored by SOFAR called bristlemouth, which is an underwater connector standard. So waterproof connectors that are kind of like power and data, so USB. And let's see if I can bring that up as well. But yeah, so the bristlemouth connector is named for the bristlemouth fish. So I had not heard of this, but the bristlemouth fish, let me bring that up. It's really interesting. I had no idea. Yeah. So the bristlemouth fish is the most common, not just fish, the most common vertebrate on the planet. There's like 2 quadrillion of these guys. They're like small fish between 2 to 7 centimeters long. They live in the mesopelagic zone, so like below 500 meters or so, and they're not commercially important. They're like very small, flimsy, watery fish that nobody wants to eat. But they have, next to insects, the most biomass on the planet, and they're the most numerous, like I said, vertebrates, and their mass is more than all terrestrial animals combined. So I learned all this today. So the bristlemouth connector is named after this. But the reason this is interesting is that these things, so they feed on plankton. So they're basically N+1 lowest level prey species. So plankton converts sunlight into, organic materials. These guys eat plankton, and then they become basically feed for the biggest predators like whales, dolphins, things that can go down that deep. And their own life cycle is very interesting. In the night, they come up to the surface and feed on their food and I guess get some oxygen as well. But during the daytime, to escape predation, they sink below 500 to around 1,000 meters. So it's every day they go up and down. Apparently, it's the largest movement of biomass on the planet. This is, I thought this was totally fascinating. And you can think of like imitating this with technology, right? Like, just to give you a calibration of how much a quadrillion is, the number of satoshis in a Bitcoin, if you multiply that by 21 million, so that's the maximum number of the smallest unit of Bitcoin you can have. So that's approximately 2.1 quadrillion. So there's approximately as many bristlemouth fish in the ocean as there are sats in all the Bitcoin that will ever exist. So that's your calibration. Huge amount. And closest comparison is ants. I think there are 10 quadrillion ants on the planet. So we are thinking at the very extreme range of like extremely high quantity, extremely simple, but still has like a very non-trivial, like, ecology. So yeah, daytime they sink into the bottom, nighttime they rise up and feed, and their job is to basically be the grass of the sea. It's like, the big whales and dolphins just eat tons and tons of these guys. Anyway, so let me see if I can pull up the bristlemouth actuator or bristlemouth connector.
You saw the machines that I posted that turned cockroaches into robot cockroaches?
Yes, I think I saw that.
Okay, so I guess you need to have something like that for these fish. Take the fish. Only problem is, communication, because radio waves don't travel so well in underwater.
Anuraj, can you share my screen again? Yeah, so this is the bristlemouth connector that David Lang was involved in. So it's named for the fish. And apparently, one of the reasons ocean robotics is so expensive is a few big defense and military contractors control it. And since the main clients are governments who don't care how much they pay, underwater connectors are super, super expensive. And it's the most expensive part of building underwater robots, making it waterproof. This is why, Mayor, I was like laughing at your point. If you ignore the making it
I'm
waterproof point,
ignoring what's difficult. Yeah.
yeah, it is actually the bulk of the cost, and this is a solution to make it radically cheaper. So yeah, it's sealed conductors, waterproofed about 300, not quite to like mesopelagic bristlemouth range, but low enough that
Yeah.
Everything except military nuclear submarines goes to about this level. So only nukes go below that, I think. But this allows you to create basically, let's see if the other side is here. This is actually from the Summer Protocols project. But yeah, it allows you to create modular underwater robots. So this is an example of a modular robot. And because you can make these waterproof connections, you can create, like this is an example of a graph. You can have multiple modules, in this case, A, B, C, D, E, connected through these bristlemouth connector cables. So this gives you not just modularity, but very small building blocks for ocean robotics. So the Lego pieces are really small. And you can imagine if this technology gets much better and smaller, maybe not quadrillions, that would be like a huge amount of technology pollution in the oceans, but you can imagine like tens of thousands of these guys just littered on the oceans, running with ESP32 class chips with Wi-Fi, local
And
mesh
we charge
networks.
them.
Yeah, this is
I don't think we have all the Lego pieces. I mean, you need some way of providing power.
yeah, that's solar. Yeah, solar. Ambient can also work if you're going up and down the water in the right gradients. That's a nice thing about going smaller and smaller and making it more and more passive. You don't actually need that much energy.
Yeah.
I was thinking like these days the drones use a lot of optical cables, right? So because of drone jamming, I think in Ukraine, people have started using these optical cables. So the fields
Yeah.
over there have been like now littered with lots and lots of optical cables. So like, can that be used in ocean settings? Do you need a copper? If you need to supply power, then you need copper wires. But otherwise, for communication, you just use optical cables, right?
I think that would create huge pollution problems. Like right now, 40% of plastic waste in the oceans is fishing nets, and optic fiber cables are basically like fishing net level pollution. But I don't
Yeah.
think they need to communicate that much. If they're on the surface, then local mesh network nearest neighbor can create a reasonably capable like wireless network. Underwater, yeah, sonar is the only usable communication mode. I think radio waves, very long frequency, I think works up to a
But
certain
elephants
depth.
use low frequency to communicate, but sound.
Yeah,
The
sonar is again,
tumblers, ultrasonic should be usable underwater, right? I don't know if it's can be used for communication, but it's a distance sensing sensor. But you could just
not
modulate.
the ultrasonic. The ultrasonic, I think, has a range of like 15, 20 centimeters, the ones we are using. But yeah, you can have, it doesn't have to be ultrasonic. It can be audible range. Who's out there to listen to you? It can just chirp, right? That's kind of like bird-like chirping. And if you make it low enough frequency, it'll propagate a reasonable amount. But I think whales communicate subsonic because, again, longer wavelengths travel better underwater. So we would go subsonic, not ultrasonic. So ultrasonic would get damped really quickly underwater, I think.
But how far can the whales communicate with each other? It should be several hundreds
of miles,
kilometers.
I believe. Yeah, whales can communicate really, really far with ultrasonic. Oh, sorry, subsonic. But this is another. I had a long discussion with ChatGPT about bristlemouth fish, this time, and I was asking, like, if there's so many, do they show any social behavior, like schooling and stuff? And apparently they don't. There's just huge amounts of them, and they occupy the same space, but they're solitary creatures. They just go up and down. They just have a lot of their not friends nearby that they're not very friendly with. So unless you're actually doing something more intelligent and complex, you may not need much communication, because communication implies like complex social coordination.
But is it something known, or is it something that is unknown and ChatGPT just repeats that?
It seems to be the most plausible hypothesis right now, so it gave me some references. But also, these are extremely simple fish. They're like pretty dumb. They're like barely smarter than plants, really.
What are these magnetic, these connectors? How are they?
I'm sorry.
I don't
Magnetic?
remember.
Magnets?
I
There's a
think
plug
no,
and
they're like
socket.
physically plugged in with O-ring seals. I remember handling a couple of these at our retreat. I don't think they're magnetic.
Okay, the
Oh, really?
O-rings push into the metallic groove, it seems.
Yeah, I mean, you need the sealing,
Yeah.
and I don't think magnets would be strong enough to create the pressure seal.
That's an interesting question.
Sorry, I didn't get it. Is there a reason why this connector is called a bristlemouth? I didn't get why.
It's named after the fish.
But why that fish?
I guess because they're inspired by the most numerous fish in the ocean. And,
okay.
yeah. Like, I think that's a direction to take robotics. Like, how simple and ubiquitous and numerous and low energy can you make it, as opposed to, like, the Mars rover, Curiosity rover, which is the other extreme of complexity, right? And that's another answer to the two-wheeler question, right?
Yes.
If control is cheap enough, you should go with 2 wheels or 3 or 4, right?
Yeah.
Make it simpler, cheaper, fewer moving parts, smaller BOM.
And importantly, also the use cases are fulfilled. Okay. So we have the question of heavier loads, okay? But the Boston Dynamics robot showed that it was 100 leaps, 100 pounds. It was 100 what? 100 something it was carrying, okay? With the 2 wheels. So even that may be a solved problem. For the tumbler, I think it can carry what, 5 kilo, something like that.
I don't think. Oh,
The Yaboom one can carry 4 kilos.
I
At
don't
least
know.
they claim.
I only tried
No.
with 1 kilo.
Not tumbler, but I think Yaboom chassis can carry 4
No,
kilo.
wait.
yeah, that one's metal, so it should have more.
Yeah.
I put a 1.5 water bottle, a 1.5 liter water bottle on top of the tumbler. And it,
Did you try to balance it?
Yes,
while
it was balancing.
Nice. So the control works with that bottle. The control algorithm of tumbler.
Yeah, that should actually make it easier. If you remember our inverted pendulum problem, if you put a bottle on it, it doesn't add any like imbalance or anything, but it raises the center of gravity. That lowers the time constant, so it actually makes it easier to balance. This is why a long broomstick is much easier to balance than a pencil, right? You can't really balance a pencil on its tip on your hand. It's too quick. But you can balance a broomstick. So taller is actually better. What makes it harder is imbalance. Like the Boston Dynamics thing we saw, it was balancing quite well, but it was also extending its arms out and holding stuff. So very asymmetrical loading it could manage. That's hard. So if we put a manipulator arm on the tumbler and put a small load on it, that'll become extremely hard for it to balance.
So for the things like Boston Dynamics 2, is there like a single control loop or like there are like multiple loops?
I think we discussed this long ago. So my best guess at the time was it uses the maneuver automaton architecture. So it's like a hybrid thing. So there'll be many small loops that are connected together in like an overall multiple mode type of architecture. and it'll move between stable, what are called trim trajectories. So like balancing upright is a trim position. It'll move between trim positions using these things called maneuvers. And you describe the whole thing with a maneuver automaton. So like it was invented for UAVs first. So for example, like, right turn, left turn, barrel roll, loop the loop, all those would be maneuvers. So trim to trim. So the Boston Dynamics robots all look like they use maneuver automaton, and these are usually trained by human supervisor pilots. So in the case of helicopters, a human pilot flew it through all the maneuvers and taught it. They got captured in the maneuver automaton, and then that became the supervisory controller. So I think something similar is probably what Boston Dynamics is doing. But I think that won't be the case for long, because the deep learning approaches, like pure reinforcement learning, where the thing stumbles around and just figures out a controller on its own, that approach I think is going to get more and more powerful.
Especially bootstrapped in simulations, right?
Yeah.
You were able to port some of the Tumblr code. What were you saying to the VBot simulator, Eric?
Oh yes, but basically I'm using the code from Eregu, the one you can download.
Yeah.
And the thing that to interface it with bots, they provide a small library. So now everything is cooked, but unfortunately the Kalman filter, maybe I've introduced a bug because it compiles but it doesn't work.
So port meaning what? Does it have a scripting language inside?
No, it provides tiny SDKs in C, C++, Python, and so on.
Okay.
So basically it's like writing a main function, okay, with the SDK and call whatever your controller is. Okay. So here the controller for Eregu is in C++. So that's why I use the bindings of Weebot in C++.
So you shouldn't even need a Kalman filter, right? Because you're not really needing to sense anything. You can just directly get the geometric coordinates and give it the feedback variables. You don't need to estimate it from an IMU.
So, right now, what I'm trying to do is as much as possible to use their code. Okay, so their code uses the Kalman filter. So, okay, for the moment, I'm just trying to make it work as it is. And for me, what's interesting is that since I have built a kind of a continuous integration platform for robotics, that boots a simulator for you, okay, and runs your tests and whatever, and report on that, including videos taken in simulations to show when something falls or whatever. Okay, we can configure all that.
Nice.
I'm just trying to get their code, and after to provide us basically the settings to improve or to test IDs and so on. So, for example, what you just said, Venkat, on removing the Kalman filter and just rely on the geometries is something we could try and immediately simulate in simulate and get the feedback.
Can we use an AI to search or explore the design space using such a continuous integration system?
So we can do that, okay, but it's a stretch for what the platform can do now, okay. But it's possible, yes.
I need to go because it's concerning. Thank you. It was very interesting.
Okay.
All right.
Well,
So I won't be there next week. I have my full week-long event, but I'll be back 2 weeks from now.
Okay.
Bye.
See you. Bye.